Hello guys, welcome on to the Max lecture series. So in this session, in this series we will be learning how to solve various functions under single integration. I hope you all understood so far the content whatever that I have delivered. If you really understand, don't forget to click that like button and also share it with all our friends. See, take the one more function. The given it is, let f of be a real valued function of a real variable defined as, how they have defined it, f of x equal to x minus closed interval of x, where closed interval of x denotes the largest integer less than or equal to x. Then the value of the integral is dash. Okay, integral is given, see there, from 0.25 to 1.25 f of x into dx is dash, whereas already f of x is clearly defined here, x minus closed interval of x. Now, before looking into this integration part, first we should understand the difference, that is actual meaning of this closed interval. What they are defining, the definition for the closed interval is given. This is standard, you can follow it up. See there, this closed interval of x denotes the largest integer value, but it should be less than or equal to x. Sir, what is the actual meaning of this? Suppose if you are taking the interval, if I am taking the value of x equal to some limit is given, right? Let us assume what they told, let me define. Denotes the largest integer value less than or equal to x, means if you are taking x equal to 0.5. Now tell me, then what is the value of closed interval of x? 0.5. From the 0.5, select two neighborhood points, neighborhood integer values. Right hand side neighborhood value is 1, left hand side neighborhood value is 0. Okay, it means x lies between 0 and 1. Yes or no? Some fractional value is given. Now it is your responsibility to identify the next and before integer values. It means left hand side 0.5 lies in between two integer values. One is 0, another one is 1. Suppose if I am taking x equal to 1.2. Tell me what is the nearest integer values in the left and right hand side. In the left hand side nearest integer value is 1, right hand side nearest integer value is 2. Suppose if the given value is 4.6, tell me what will happen. Left hand side the nearest integer value is 4, right hand side the nearest integer value is 5. Suppose if the given value is 7.9, what will you tell? Right hand side nearest integer value is 8, left hand side nearest integer value is 7. Now, actual meaning of x, closed interval of x is, when the moment you are defining certain value for x, it is very important to cross check the largest integer value which is must be less than or equal to x. Do you understand? Less than or equal to means x I am defining 0.5. So largest integer value should be less than or equal to 0.5. Integer value means I cannot take 0.5, but less than 0.5, and integer means 0. Again, if you take the second one, see there, 1.2 is the value of x. Now, what is the nearest integer value which is must be less than or equal to 1.2? Nearest integer value is 1. See there again here, 4.6. X, closed interval of x means less than or equal to nearest integer value 4. 7.8 means nearest integer value 7. So, here how can I say? Mod of x is 0 for this, here mod of x is 1, here mod of x is 4, here not mod x, closed interval of x. So here the closed interval of x is 0, here the closed interval of x is 1, here it is 4, here it is 7. Did you understand? I hope you all got the clarity about this, whatever that we have been observed here, you all got the complete clarity. That's all. So this is how we are defining the closed interval of x. See, you have to understand that. So suppose if the value of x is directly given as 1, then what shall I do? 1 itself, it is the integer value only. So you can directly take, because they told less than or equal to. If x equal to, x is defined as 1, then the integer value, closed interval of x should be less than or equal to x. But it should be an integer. If x is integer, then you can directly take that value. If x is not an integer, then choose the nearest less than integer value. Like if x is given as 1, then directly you can take closed interval of x also equal to 1. Suppose if x is 1.2, then nearest left hand side integer value is 1. You should choose nearest less than 1.2 integer value. Before 1.2 you will be having integer value is 1 only. So your answer should be like that. Shall we proceed now? I hope you all got the complete picture about the closed interval. Closed interval of x. Let us take the given function. It's very easy, direct integration only. Just we will be simply dropping the answer. Given it is integral of 0.25 to 1.25, they said f of x into dx. How can I redefine this function? Let us break it one by one. See there, I can write this function as, how can we write? 1 minute. Yes, see, this function can be written as 0.25. Here the limit is going to be 1.25. f of x can be written as x minus closed interval of x into dx. It can be further written as, you can break the limits into two of 0.5 to 1.25 into x into dx minus interval 0.25 to 1.25 into closed interval of x into dx. Now here the value of limit x is defined 0.25 to 1.25. Sir, how can I break these limits further? Initially I was telling you, if the x value is fixed, then we can easily choose the nearest integer value. Now if you observe, here the limit is defined between two fractional values, between 0.25 to 1.25. What you have to do is, whenever your limit has been defined in this way, just break it into two of, because listen, if you select 0.25 alone, the nearest integer values are, left hand side we have 0, right hand side we have 1. If we will select 1.25, then what is the nearest integer value? Left hand side it is 1, but right hand side it is 2. So completely here we have two set of intervals in order to solve this function. Are you getting me? If the interval is lies between 0.25 to 0.75, like only two integer values are, if there is a chances of getting only two integer values, then we can directly define the answer. Sir, x will become, both values of x are lies in between 0 to 1, so nearest integer value is 0. So we can take closed interval of x equal to 0 only, sir. But here we will be having two values for closed interval of x. How it is possible? Between, if I will select 0.25, then the interval should be 0 to 1. If I will select 1.25, then the interval should be 1 to 2. So how can I break these limits? Let us see. Keep the first one as it is, or you can also complete the integration of first one, like you know how to integrate x with respect to dx, minus, closely observe how I am doing this. I am breaking these limits 0.5 to 1, closed interval of x into dx, and this minus is common, right? So here also minus will come. See, because here we have a common minus, it will get multiplied in both of these cases. Second interval is going to be 1 to 1.25, maximum limit into closed interval of x into dx. Do you understand? So whenever, suppose let me take an example for your understanding. Suppose if the limit is defined as, I am talking about limit, if the limit is defined as 0.2, 0.35 to 2.25, how will you define for closed interval of x? Now the question is, you have to identify the value of closed interval of x into dx between the limit 0.35 to 2.25. How can I define this? See, take 1.25, that we got, because we cannot break three limits here. 1 minute. See, otherwise take the direct value. So 2.25 is given, sir. How can I proceed further? If 2.25 itself it is given, let me tell you, this limit can be broken. How will you break it? First start from 0.35 to 1. We will be having certain limit. Then again we should travel from 1 to 2, we will be having certain limit. Again we should travel from 2 to 2.25. See there how I am breaking the limits for closed interval. So it is very important to break it, because we have to identify the points. 0.35 is basically lies between what? 0 and 1. Mostly they won't go with this many things, because one value obviously will become 0. So they will be focusing on only two things. like what they will give you is 0.752, they will be giving you 1.25. So what can we do, sir? This can be written as, you have to break this 0.75 to 1, then I can take 1 to 1.25. Like that you have to break the closed interval limits. I hope now you got the complete picture about the closed interval. According to the closed interval, 1 minute, yeah. Okay, now take the function and proceed further in order to bring the answer for our question. What you will be getting, if I will integrate x, it will become automatically x square by 2. You know how to proceed further. From here you can put 0.25 to 1.25, no issues. Again, the second case will become minus, what you will be getting here? See there, I have to figure out the value of closed interval of x now. Tell me, what is the closed interval of x? Sir, between 0.25 to 1. The nearest integer value, which must be what? Less than, you should not, when you are considering, see 0.25 to 1, what is the nearest integer value? You have to take the least value, and from 0.25, what is the less than to that? That will be 0. So you have to take 0 into dx. And your limit you can continue 0.25 to 1 undoubtedly. What you will be getting for second one? Between 1 to 1.25, the nearest integer value, which should be less than your maximum limit. Remember, see there, 1 is given here, 0.25 is given. Basically, we have 2 points only. One is 1.25, another one is 0.25. We have only 2 points. So you should select first one, 0.25. 0.25 less than 0.25, nearest integer value is 0. Here we are traveling up to 1.25. So less than 1.25, nearest integer value is 1. So the value of x will become 1 into dx. Again the limit is same, 1 to 1.25. Hereafter you can proceed further. I hope there is no point of bringing the solution. We know 1.25 whole square, it will become 1.25 whole power 2 minus 0.25 whole power 2 whole divided by 2. And similarly here it will become, see there, I did a mistake here, minus should come, because according to the derivation we have to keep the minus here. They told integration of 1 with respect to dx will become x, and the limits are going from 1.25 to 1. Now if we compress this whole, approximately, see exactly I am getting 0.5. That's all. This is how we are solving the questions when closed interval of x will be given to us. I hope you all got the complete idea about this. If you don't understand this, watch one more time. Nothing will be wrong here. So this is all for this lecture. Remaining things we will see in the next class. Thank you all.